And finally, the last question of this test, we're asked to write a rule and equation that matches the graph below. So I can read from this graph that this particular linear relationship has a change in y of 4 units, and I'm told that there is a change in x of 5 units. So from that, I know that my slope is positive, and I can see that from the fact that this is moving up as I read from left to right, and the slope is up 4 over 5 units. Unfortunately, I don't have the y-intercept visible to me, um, and I suspect it is actually at -3. But I'm going to confirm that algebraically, and I'm going to do that by starting with the equation of a line, right? Y equals mx plus b, and I'm going to use this point that I have that's on the line. You can see on that point, I'm told that y is -7. I know the slope is 4/5. We just discussed that. And I'm told that x is -5 and then plus b. So the beauty of this, right, starting with a line, and plugging in a particular point in the slope that we know, we can calculate the y-intercept and then we can write the equation of this particular line. If I clean up the right-hand side, the left-hand side is -7, but over on the other side I've got a 4 times a -5 and then divided by 5. Well, you can see the 5 over 5 forms a giant 1, but I've got this -1, this negative left over. And also 4 times -5 is -20, and -20 divided by 5 is 4. So this is -7 equals -4 plus b. And if I add 4 to both sides, I get that -3 is my y-intercept. And that's exactly what we could see, right? We were suspicious that it was. And actually, if I start at this point and I go up 4, there's up the 4, and then over 5, you can see I do land exactly at that point. So it's not close, it's actually right there going through the -3. So we know the equation of this line. It absolutely must be, and I'll write it up here on this line, y equals my slope, which was 4/5 x, and my y-intercept was -3, so I'll write -3.